Guys, stop. I need you to look at this number, 247 degrees Celsius. That was the temperature inside the crater of Mount Slamet. September 2024, 247 degrees. Now look at this one, 401 degrees Celsius. That is what the thermal cameras showed on April 2nd, 2026, 12 days ago. 401 degrees. That is a jump of 164 degrees Celsius in less than 18 months, inside the crater of Indonesia's second highest volcano, on the most densely populated island on Earth. And that temperature rise alone, that would be alarming enough. But it is not just the heat, it is where the heat is. Because when the scientists looked at the thermal images, they did not just see a hotter center. They saw something that should make every volcanologist in the world sit up. The distribution of hot areas expanded to include a circular pattern of hotter areas around the crater walls. This distribution suggested the development of a fracture system. Smithsonian Institution, a circular pattern around the crater walls. A fracture system. The mountain is cracking from the inside with heat. And I am going to show you exactly why this matters, exactly what this means, and exactly who is living in the shadow of it. Don't go anywhere. Let me tell you where Mount Slamet is, because location is everything in volcanic risk. Mount Slamet, which has a height of 3,428 meters above sea level, stretches across the districts of Banyumas, Purbalingga, Pemalang, Tegel, and Brabus. VOI 5 districts, not 1, 5. This volcano sits on the boundary of 5 populated administrative regions in central Java, Indonesia. Slamet is Java's second highest volcano, located in central Java approximately 20 kilometers north of Purwokerto. Volcano live 20 kilometers. That is the distance between the volcano's summit and the city of Purwokerto, a city of over 300,000 people. 20 kilometers. And the broader population zone surrounding this mountain, stretching across those 5 districts, contains millions of people living under a mountain that is heating up, that is cracking from the inside, and that has not erupted since 2014. 12 years of pressure building. Now let me take you through the timeline, because this has not happened overnight, and this is the part that nobody in the mainstream media is putting together properly. Beginning in May 2024, the seismic network detected an increase in the number of deep volcanic earthquakes, followed by an increase in the number of shallow earthquakes and continuous tremor. Smithsonian Institution, May 2024. That is when it began, not April 2026, not last month, nearly 2 years ago. Deep volcanic earthquakes, then shallow ones, then continuous tremor. A progression, a staircase of escalation, step by step, moving upward. And then the earthquakes began to intensify on 22nd March, with signals becoming more distinct, and then became more numerous on 27 March. Smithsonian Institution, March 22nd, more intense, March 27th, more numerous, and then deformation data indicated magma migration to shallower depths. Smithsonian Institution, magma migration to shallower depths. 3 words that change everything. The magma is moving up, not sideways, not deeper, up, toward the surface, toward the crater, toward the fracture system that is forming. Now I need to explain something, because fracture system developing in the crater walls sounds technical, it sounds distant, it sounds like something that happens in a geology textbook. Let me make it real. Imagine the crater of Mount Slamet like a bowl. The walls of that bowl are rock, solid rock, formed over thousands of years, cooled and hardened. Now imagine something very hot pushing up from below, super hot gases, superheated fluid, magma rising. As that heat contacts the rock walls from the inside, the rock responds, it expands, it cracks, and those cracks form in a pattern, a circular pattern around the walls, like rings, like the mountain is opening itself from the inside. That is what the fracture system is. That is what the thermal cameras detected on April 2nd. The heat had spread from the central floor of the crater out to the walls, in a ring, in a circle, suggesting that the fracturing is happening uniformly around the crater, not in one spot, not in one fault line, everywhere, all around. And that matters because it tells scientists something specific. It tells them that pressure is building from below, evenly, not from one side, from below. And now, On 3rd April, white plumes began continuously rising as high as 300 meters above the crater rim. Smithsonian Institution, the very next day. After the fracture system was detected, white plumes, 300 meters above the rim, continuously, not intermittently, continuously. That is the mountain exhaling, releasing pressure through the new cracks, through the fracture system, gas finding its way out, where before it had nowhere to go. Now, here is what I want to show you about the seismic story. Because the seismic story at SLAMET is extraordinary when you see it laid out completely. The Smithsonian Global Volcanism Program has been tracking this, and the signal sequence is a textbook escalation pattern. May 2024, increased deep volcanic earthquakes. These come from deep within the crust, from magma movement at depth. Then, increased shallow volcanic earthquakes, magma moving higher. Then, continuous tremor. Tremor is not discrete earthquakes, it is sustained vibration, the sound of fluid moving through rock, continuously, without stopping. Then March 22nd, 2026, intensification, signals becoming more distinct. The seismometers are hearing something louder, something closer. Then March 27th, 2026, more numerous signals, more events, more frequently, more energy. Then deformation data, magma at shallower depths. Then April 2nd, temperature jumped to 401 degrees Celsius, fracture system detected. Then April 3rd, continuous white plumes 300 meters above the crater. This is a step function. Every step goes up. No step comes down. That is the pattern. And that pattern has a name in volcanology. It is called pre-eruptive unrest. Now I am going to tell you about Mount Slamet's history, because history is prediction, and Slamet has a lot of it. Historical eruptions recorded since the 18th century have originated from a 150-meter deep, 450-meter wide, steep-walled crater at the western part of the summit and have consisted of explosive eruptions generally lasting a few days to a few weeks. Volcano discovery explosive eruptions, lasting days to weeks since the 18th century, and the frequency, the last confirmed eruption of Slamet occurred in 2014. Since 1772, Slamet volcano has had at least 42 historically documented eruptions. This means that it erupts on average every 6 years. Volcano discovery every 6 years on average. The last eruption was 2014. That is 12 years ago, double the average interval. The volcano has been quiet twice as long as it normally is. Twice as long. And all the while, deep earthquakes, shallow earthquakes, continuous tremor, deformation, magma rising, temperature jumping 164 degrees, crater walls fracturing for nearly 2 years, building, building, building. Now let me tell you about what the 2014 eruption actually looked like, because that is the most recent benchmark we have, and the comparison to what is happening now is striking. There was a dramatic increase from 6% to over 70% in the dissolved carbon dioxide content of a hot spring on the south side of Slamet during 17-20 March 2014. Smithsonian Institution CO2 content jumped from 6% to over 70% in 3 days. That is a signal of magma degassing near the surface, magma releasing gas into the groundwater, into the springs. And then what followed? One active period was 9/11 September, when brownish steam plumes rose to 1/500 meters and incandescent lava ejections were observed up to 600 meters above the summit, more than 200 times. Smithsonian Institution. More than 200 incandescent lava ejections in 2 days, up to 600 meters above the summit. On 17th September, a 200-meter-high ash plume drifted south and southwest from the summit. Ash deposits 0.1, 0.2 millimeter thick were reported 20 kilometers south of the volcano. Smithsonian Institution 20 kilometers south. That is Purwokerto. Ash fell on Purwokerto in 2014 from an eruption that began with the same seismic sequence we are now seeing again. Deep earthquakes, shallow earthquakes, inflation, tremor, and that was the 2014 precursor sequence, the one before the explosions, the one before the 200-meter ash plumes, the one before the 200 lava ejections in 2 days. Now, here is what makes 2026 different from 2014, and this is the part I have not heard anyone explain clearly. In 2014, the eruption was a level 3 event on Indonesia's alert scale, significant, explosive, but relatively contained. In 2026, we have a fracture system. That fracture system was not present in the 2014 lead-up. The 2014 sequence was a fairly standard magmatic escalation, deep to shallow, gas to lava. The 2026 sequence includes something extra, the walls of the crater developing a ring of fractures. That is a structural change, not just a temperature increase, not just more seismicity, a physical change to the architecture of the volcano's summit. And what that could mean is that when Slamet erupts this time, if the fracture system has progressed enough, the eruption could start with a collapse of part of the crater wall, not just an explosion from the vent, a wall collapse, which would immediately change the direction of any blast, any pyroclastic flow, any ash column in ways that 2014 did not present. Now, I want to put you in the shoes of someone living in the 5 districts around Slamet, because this is not abstract. This is their daily reality. Mount Slamet borders 5 districts in central Java province, namely Brebes, Banyumas, Purbalingga, Tegal, and Pemalang. From March 2014 to January 2015, Mrs. Slamet started to have unpredictable fluctuation in seismic activity. Huge explosions occurred in March, August, and September 2014, which were the biggest explosions compared to the previous ones in the 20th century. PubMed Central biggest in the 20th century, and these communities lived through it, and they rebuilt, and they stayed because they are Javanese communities, ancient relationships with the land, with the volcano. They know what it feels like when Slamet stirs. To live in this natural disaster-prone area, specific household characteristics are essential. Households in disaster-prone 2 area had limited assets and were required to identify factors influencing disaster management. PubMed Central limited assets. These are not wealthy communities with resources to relocate at will. These are farming families, their land, their livelihoods, their ancestral connection. And they have heard the warning before. They know the drill. But they also know what it costs to leave. And they know that most of the time, the mountain grumbles and settles, and they go back and life continues. The question right now is whether this time is different. And here is what the PVMBG, Indonesia's Volcanic Monitoring Authority, has to say. The alert level at Mount Slamet remains at level 2, on a scale of 1 to 4. Level 2 is called Waspada in Indonesian. It means caution. The public is warned to stay out of a 2-kilometer radius of the summit crater, not level 3, not level 4, level 2. And I want to be precise here, because precision matters. Level 2 does not mean nothing is happening. Level 2 means something is happening and we are watching carefully. Level 3 means hazardous eruption is possible. Prepare evacuation. Level 4 means eruption is underway or imminent. Slamet is at level 2 and has been since October 2023. This mountain has been on alert status since October 19, 2023, following increased seismic activity, visuals, and other parameters such as the temperature of the spring around the slope. VOI, October 2023, alert status for over 2 years. Continuously, no pause, no drop back to level 1, just steady level 2. Building, 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 until now, when the crater temperature jumped 164 degrees in 18 months and the walls started cracking. Now I want to connect Slamet to the bigger picture, because this is the insider piece, the piece that puts it all in context. Right now, in April 2026, we have Kilauea in Hawaii on its 44th eruption episode, Mayon Volcano in the Philippines on day 97 of continuous eruption, Dukono in Indonesia producing 199 explosive events in a single monitoring period, and now Slamet, the second highest volcano on Java. 5-kilometer exclusion zone radius, millions living within potential impact range, heating up, cracking, building. All of this is happening simultaneously. All of this is happening on the same ring of fire. All of this is happening as the Pacific Plate drives one of the most active tectonic periods in recent years, with three major earthquakes in the region just weeks ago, with three simultaneous cyclones forming, with a super El Nino building beneath warm Pacific waters. None of these things directly cause each other, but all of them share the same foundation, the same restless planet, the same stressed system, and Slamet sits directly on top of one of the most dangerous parts of that system, the Java subduction zone, where the Indo-Australian plate is diving beneath Eurasia, melting, rising, feeding dozens of volcanoes along a single chain, and Slamet is second highest among them. Let me now give you the context on what the 2014 eruption cost and what a repeat or a larger event could mean. In 2014, ash fell 20 kilometers from the summit, covering Purwokerto, disrupting agriculture, contaminating water sources, grounding aviation, forcing evacuations from danger zone communities, and that was a relatively contained event, VEI2, on the Volcanic Explosivity Index. The last confirmed eruption of Slamet occurred in 2014. Historical eruptions have been recorded since the 18th century, with its most recent events being in 2009 and 2014. Its summit is Central Java's highest point, highest in Java after Semeru. Volcano Live now imagine an escalation, not VI2, but VI3 or VI4. Ash column reaching not 1,200 meters, but 3,000 or 5,000, drifting over cities, over agricultural land. Java is not just any place, it is the most densely populated island on Earth. More than 150 million people on an island, roughly the size of the U.S. state of New York, and Slamet is 20 kilometers from one of its major cities. The ash footprint of a VEI3 eruption at Slamet could cover hundreds of square kilometers, contaminate water supplies across multiple districts, collapse roofs under ash weight, ground aviation at multiple airports, devastate the agriculture that millions of Javanese families depend on. Now let me talk about the white plumes, because this is the detail that connects temperature to behavior. On the 3rd April, white plumes began continuously rising as high as 300 meters above the crater rim. Smithsonian Institution white plumes, 300 meters. Continuous. In isolation, white plumes are often water vapor, steam, hydrothermal activity, not necessarily magmatic, but in the context of 18 months of escalating seismicity, in the context of deformation showing magma at shallower depths, in the context of 164-degree temperature jumps, in the context of fracture systems developing in the crater walls, white plumes are not reassuring. White plumes are the mountain breathing, through new openings, through the fractures, through the cracks that formed because the heat is so intense that it is physically breaking the rock. That is not nothing. That is a very specific something, and volcanologists know what it means. It means the conduit is opening. The pathway from depth to surface is being prepared by the heat itself. Now, here is what I am watching for. The signals that would tell me this is accelerating. First, watch for a change in the color of the plumes, white to gray. Gray means ash. Ash means magmatic material is reaching the surface. That would likely trigger a level 3 alert. Second, watch for tremor amplitude. The continuous tremor that has been recorded, if its amplitude increases sharply, that is magma moving faster, more violently, closer. Third, watch the deformation data. If the volcano starts inflating rapidly, ground moving upward, measurably, that is magma volume increasing near the surface, building toward a discharge. Fourth, watch the CO2 and SO2 measurements at the springs and vents. Just like 2014, when CO2 jumped from 6% to 70% in 3 days, gas chemistry changes are one of the fastest warning signals. If SO2 starts spiking, that means fresh magma is degassing, fresh magma very close to the surface. Fifth, And this is the one I am watching most carefully. Watch for any change in the fracture system pattern. If the fractures extend, if new cracks appear, if the circular pattern becomes asymmetric, favoring one direction, that would tell you which way a potential blast could be directed, and that changes the risk profile entirely. Now, I want to say something directly, something honest, because I always want to be honest with you. Slamet may not erupt soon, it may settle, the heat may plateau, the seismicity may ease, the fractures may stabilize without progressing. Indonesia has dozens of volcanoes at alert level 2 at any given time. Most of them do not escalate to eruption. The PVMBG is watching this closely. They are experienced. They have monitoring infrastructure in place. And they have not raised the alert to level 3. That is a measured professional assessment. I respect it. But here is what I also know. The temperature jumped 164 degrees in 18 months. Magma is confirmed moving to shallower depths. Earthquakes are intensifying in frequency and distinctiveness. A fracture system is forming in the crater walls, and the volcano has not erupted in 12 years, double its average interval. All of those things are true simultaneously, and they point in one direction, not toward quiet, toward something. So here is the practical question. What should the people of Banyumas, Purbalingga, Pemalang, Tagal, and Brabis do right now? Follow PVMBG guidance. That is the first and most important answer. Stay outside the 2-kilometer exclusion zone. Monitor the official alerts at https://magma.esdm.go.id, Indonesia's official volcano alert website. Know your evacuation route. This is a community that has evacuation routes established. They have done this before. Banyumas Disaster Mitigation Agency head Ariono said the BPBD has prepared mitigation efforts in the case of an eruption, such as determining evacuation routes and ensuring that all warning signs are installed. Relief Web. The routes exist. The signs are in place. The preparation has been done. But preparation means nothing if you do not know to use it. And the window to evacuate safely, once Slamet decides to move, based on 2014, can be very short, shorter than people expect. And for those watching from outside Indonesia, this is worth your attention. Not because it is your immediate problem, but because this is how Earth works. This is a planet in motion. Slamet has been building since May 2024. The fracture system appeared April 2nd, 2026. The white plumes started April 3rd. And the Smithsonian Global Volcanism Program, the gold standard of global volcanic monitoring, just flagged it in their weekly report, alongside 23 other actively significant volcanoes this week. This week, that is what the world looks like right now on this planet in April 2026. And Slamet, the second highest volcano on the most densely populated island on Earth, is heating up, cracking from the inside, building towards something. And it is time to pay attention. I am going to keep watching this. Every update from PVMBG, every seismic report, every thermal image, every change in the fracture system pattern, every shift in the plume color. And the moment something changes, you will hear it here first. Subscribe. Hit the notification bell, because the next update on Slamet could come at any time. This is a story that is not finished, not even close. Stay safe, everyone. Bye-bye.